Hello there. We've just reviewed conducting a risk assessment and now we're going to cover hazard controls beginning with engineering control measures. In the next part of this training, I'm going to talk about chemical fume hoods. A fume hood, when used properly, is one of the most reliable engineering controls in the laboratory. They protect you by containing vapors, dusts, gases, and fumes generated in the hood, and remove them as air flows into the hood and out the exhaust system. The hood sash also shields you from splashes, fires, and minor explosions that could occur inside the hood. But, if you don't use the hood properly and adequately analyze the hazards associated with your work activity, you won't get the full safety benefits of this important piece of equipment and you could be exposed to harmful fumes generated by your work activity. So let's talk about what you need to do to ensure it operates properly. Let's first talk about the parts of a fume hood. Bypass fume hoods, as seen here, are typical end nest. They are designed and constructed to allow room air to enter the fume hood by a route other than the sash opening. Bypass hoods have a grill at the top where air enters. This limits the increase in face velocity through the sash opening and results in a relatively constant exhaust airflow rate. The sash, along with the bypass grill located above, determines the airflow characteristics of the fume hood. The baffles, in the back of the hood, direct the air to follow specific air patterns within the hood and also support a uniform air velocity. Fume hoods are typically connected, via ductwork, to an exhaust fan, usually located on the roof of the building where the hood is located. The exhaust fan draws air from the room where the hood is located, in through the hood opening, and out through the ductwork. The airfoil or sill, located at the front of the hood beneath the sash, creates a smooth airflow, minimizing turbulence of the air entering the hood. Now that we discussed the key parts of a fume hood, let's talk about how to use it safely. Most safe practices focus on preventing the disruption of proper airflow and cross drafts. Before you start your activity in your fume hood, confirm that it has been certified within the past 12 months. NIST's chemical fume hoods are inspected and tested annually by OFPM for functionality and condition. A certification sticker is placed on the front of each fume hood indicating when the last inspection was done, by who, and at what conditions. After you check that the hood was certified in the past 12 months, turn it on, and raise the sash to the set point marked on the hood. Now, look at the airflow monitor to see if it is functioning properly. If either the visual or audio component appear to be in alarm mode, call the safety office for assistance. A fume hood alarm goes off for two main reasons: the sash is at an unsafe height or the airflow is too low to be able to effectively capture and eliminate contaminants. Check that the face velocity measurement on the airflow monitor is close to the face velocity on the sticker. It's okay if the monitor reading is plus or minus a few points. If your hood doesn't have a monitor, verify airflow by taping a piece of tissue to the sash, like I'm doing here. As you see, the hood is working as it should and drawing the tissue in through the sash opening. The lower the sash, the more draw. The higher it is raised, the less it draws. Work with the fume hood sash in the lowest possible position. No higher than 18 inches. So it can act as a physical barrier if an accident occurs in the hood. All work should be done at least 6 inches into the recessed area behind the sill. This will help to keep materials from escaping the hood when there are air disturbances. Keep the fume hood clean and clear of unnecessary chemicals, glassware or equipment. Avoiding clutter will provide optimal containment by preventing turbulent currents. Use blocks or racks to elevate equipment 1 to 2 inches off the fume hood deck surface, so that air can easily flow around all apparatus with no disruption. You also want to avoid having electrical cords or hoses crossing or resting on the bottom airfoil or cutting across the sash because this can disrupt the airflow. Speaking of electrical safety, plugging electrical equipment in the hood into electrical receptacles located outside the hood reduces the risk of chemical or electrical fires. When leaving an activity in the hood unattended, first label chemicals in the hood and close the sash before you leave. But don't turn the hood off if chemicals remain inside. You also want to avoid creating cross drafts while working in the hood. A cross-draft can pull contaminated air out of the hood and into the air you're breathing. The kind of situations that can cause cross-drafts or turbulence that you want to look for include doors opening and closing, fans in the room, rapid movements like raising and lowering the sash too quickly, and people walking by.
Gosh, I think I left the hot plate that I need in the back of the lab.
People simply walking by the hood can cause air disturbances. That's why your hood should be located away from walkways. Do not evaporate or store chemical wastes inside the fume hood for long periods of time. A hood's exhaust does not usually have environmental controls on it, which is why you should not use it to dispose of hazardous chemicals by intentionally venting. Contaminated materials should be removed from the hood only after they've been decontaminated, or if placed in a closed outer container to avoid releasing contaminants into the lab. In case of a power outage, the hood sash should be lowered within an inch to maintain a chimney effect to keep some air flowing into the hood. Keep the sash closed when the hood is not in use and turn off its light to conserve energy. During this video, I only covered general safe practices, but before working in a hood for the first time, you should be trained on how to operate that specific hood properly. If you have any questions about your fume hood, talk to your supervisor, your group or division safety representative, or contact the Office of Safety, Health, and Environment. Also read the fume hood safety requirements in NIST's chemical management program located on the safety website.